Biomass-based energy generation is one of the major focus areas of renewable energies in India. The strength of India's biomass resources mostly lies in agricultural sector. A large quantity of crop residue biomass is generated in India. India produces 686 MT gross crop residue biomass on an annual basis, with Uttar Pradesh being the highest producers. Among all the crops, sugarcane produces the highest amount of surplus residue, followed by rice. However, large chunk of straw is either left in field as waste or sometimes burnt in many parts of the country. Concern has been raised for two instances. First is the methane emission when straw is left uncollected or allowed to decompose in the field. Second, release of atmospheric pollution like carbon dioxide, aerosol, etc. when burnt in the field. Continuous efforts have been made for the development of biogas in India through various schemes and initiatives. Here is a brief historical overview of government support for biogas development in India. In spite of the sustained efforts by the government, there has been a downward trend in the growth and utilization of biogas. This is because of the hassles faced during the running of the household biogas system. Major fraction of the crop residue are openly burned, because of which environmental and health hazard problems are caused in the process. This happens because as the characteristics of the crop residue are unknown and unconfirmed. A decade-long research was done in the Department of Energy, Tezpur University to know the comprehensive characterization of crop residue predominantly found. This is done by understanding the conversion process from crop residue to fuel and fertilizer value. Lignocellulosic biomass is the most abundantly available bioresource, amounting to about a global yield to up to 1.3 billion tons per year. Anaerobic digestion of lignocellulosic biomass like crop residues have gained attention due to their surplus availability in rural areas. However, anaerobic digestion of such biomass feedstocks require pre-treatment to increase their digestibility. Lignocellulosic biomass like rice, straw, and corn stalks are composed of lignin, cellulose, and hemicellulose fragments. Out of this, lignin is composed of an interconnected network of polymeric compounds which is hard to break down when subjected to anaerobic digestion. The presence of lignin is hindrance to the enzymatic hydrolysis of cellulose during the anaerobic digestion process. That's why pre-treatment of lignocellulosic material is very important. While chemical fertilizers have traditionally supplemented soil nutrients, organic fertilizers including byproducts from bioenergy systems offer potential for enhancing crop production and soil health. Byproducts such as digestive from anaerobic digestion and biosur from biomass gasification are inevitable in bioenergy conversion process and require proper management for sustainability. With the rapid expansion of anaerobic digestion and gasification technologies, there are simultaneous increase in the byproduct generated, highlighting the need for effective residue management in bioenergy production process. Agro-residue holds significant potential as a global bioenergy resource. Their geographic distribution and seasonal availability vary, requiring precise data for biomass power plant commissioning. Logistics such as harvest collection, storage, and transportation are specially interlinked and require detailed planning. The sustainability of a bioenergy product relies on the accurate assessment of biomass resources, efficient logistical planning, and evaluation of potential environmental impacts. The supply chain of bioenergy project consists of three interconnected elements: resource assessments, logistic planning, and power plant design. GIS intervention in bioenergy planning is essential because various agro-residues serve as energy feedstock, necessitating a spatio-temporal database for the physiochemical characteristics, availability, and distribution. Maintaining sustained feedstock supply is crucial for power plant viability. GIS help anticipate fluctuation and arrange alternative supplies during lean periods. GIS allows assessment to environmental requirements, harvest constraints, economy, technology, compete uses, socio-political dynamics, land use, and logistic facilities. India possesses a huge potential in biomass power generation to reduce dependency on fossil fuel imports. In the face of escalating global challenges, humanity is confronted with an urgent need for sustainable energy solutions. The ever-growing demand for energy, coupled with the concerns about environmental impact of the traditional fossil fuels, has spurred a decade-long research initiative led by Professor D.C. Barua and his dedicated team at the Department of Energy and Energy Conservation Laboratory.
This is about the biogas. Biogas actually the proven technology that has been used in all over the globe and especially in India. And then its history is actually very old. However, after independence, considering the energy, mostly the clean cooking fuel need, as well as the nutrients needs of the farms, the biogas has been attention of the biogas has been increased, and then there were many efforts from the government side too, and then to popularize the biogas as a small scale household or system where the decomposable materials, mostly initially the cow dung and then the crop residues too, were used for production of your biogas. The gas is a mixture of methane and then carbon dioxide, but methane is this flammable part, and then it is equivalent to any clean cooking fuel, and it is to be used for cooking purposes as well as for space heating is required.
Over the past decade, Professor Borua's team has undertaken a comprehensive approach to address this issue. The research efforts concentrated on conducting experiments with diverse waste materials sourced from households such as kitchen waste, crop residues, undesired vegetation. Multiple trials were undertaken considering aspects like feedstock preparation, co-digestion characteristics, and the implementation of an intelligent biogas management system, all aim at ensuring a longevity and economic feasibility of the system. The primary objective was to enhance the production of biogas comprising mainly methane while extensively exploring the digested potential application as crop nutrients or alternative to conventional chemical fertilizers. As a part of the initiative to utilize the biogas generated in the campus, Tezpur University installed a 50 cubic meter per day capacity biomethanation plant in one of the students' hostel. The biogas plant model Sakti Surabhi was installed in 2014 along with a nutrients recover facility designed to recycle digested nutrients. The solid part of the digested is mixed with the waste vegetative materials which are not used as a biogas feedstock in a separate vermicomposting chamber for preparing organic fertilizer, and the liquid part generated by the system is applied in a vegetable garden in the vicinity of the biogas plant besides selling to customers at a full capacity. Utilizing 250 kg of kitchen waste, the plant has a potential to generate 20 kg of LPG equivalent biogas daily. However, actual output varies between 12 to 15 kg of LPG equivalent biogas per day based on the ambient condition, feed material characteristics, and quantity. The plant has a capacity to generate about 300 kg of solid organic fertilizer per month. The team's ongoing efforts are dedicated to showcasing the practical use of biogas as a thermal source, particularly in cooking applications. In an effort to enhance viability and promote widespread adoption, a mobile unit known as Zibika has been ingeniously designed to operate within the Tezpur University campus. This mobile eateries relies on biogas system to meet its thermal cooking energy demand. The success of this model has been fully demonstrated, indicating the potential for replication in other communities, educational institutes, or organizations. This innovative approach facilitates complete nutrient cycle, reduces reliance on fossil fuels, and create exciting business opportunity. In conclusion, the journey of the decade-long research initiative represents a significant stride towards sustainable energy solutions. The team's relentless efforts, innovative approaches, and groundbreaking discoveries underscore the potential for transformative change in addressing the global energy challenge. As we navigate towards a future characterized by environmental consciousness and renewable energy, initiatives like this serve a beacon of hope, illuminating the path towards a more sustainable and resilient world.